So in the previous class, we have discussed about the conditional probability Bayes theorem, which is useful to find the posterior probability, right? Now, after that here, when we find the probability, that is not enough. But again, we have to find the value of that experiment also. So that value of the experiment can be found using random variable. So what is a random variable, right? If we consider the simple example, right? If we just, let us consider that a cricket match. So a cricket match means it is played between two countries, right? So let us consider India and West Indies, right? You are seriously watching the match, and after the completion of the match here, you are very happy that India has won the match. But if someone asks you, right, what is the run rate of India, or with how many runs India has won the match, then you say that with 2 runs or with 4 wickets India has won the match. So what is this 2 runs or 4 wickets is nothing but that value of the game, right? So that means here, whenever you conduct an experiment, right? So that is the final result of the experiment you will get. But that experiment has some value here. So that value is nothing but a random variable. So clearly, if we define the random variable, it is nothing but assigning a constant to the sample space of a random experiment, right? So I am stressing here random experiment. So what is this random experiment? So random experiment means here, the performing an experiment is in my presence, and even the occurrence of the result is also in my presence. That is called the random experiment here. Now, this random variable is useful to find the number of semiconductor wafers that need to be analyzed in order to contaminate the p-type and n-type wafers here. And also it is useful to find the angular velocity of a circuit. So whether it is accepting the current or not, how much current it is accepting and how much current it is rejecting. So that we can find using this random variable. So this random variable statistically defined as a mapping from sample space to real number space. So it is given as X maps S to R, where X is a random variable, S is a sample space, and R is a real number, a constant. Or simply we can define it as assigning a constant value to the event of a sample space. So for example, if you consider the basic example as tossing a coin, the sample space is head and tail here. So if I am giving the value 1, those who are getting head, and value 0, those who are getting tail. So that is 1 and 0 are called the random variables here. You can see the example of this in this slide. Then this random variable is classified into 2 types as discrete random variable and continuous random variable. So what is this discrete random variable? A random variable which takes countably finite values is known as a discrete random variable. So for better understanding, you can consider your class. Suppose your class has the strength 60 students, right? So this 60 student strength is limited for your current semester. So the number of absentees or the number of presentees will be within those 60 only. So there is a limit for that. Means it takes only countably finite values. But again, if you consider the entire college strength, it may be some 5,000. So out of this 5,000, right, the number of absentees or the number of presentees can be from number 1 to 5,000, any number. So there is no limit for that. But if you consider only the strength of a class, it is fixed to 60 students. So 1 to 60 is countable here. So a discrete random variable is defined as a random variable which takes countably finite values. Example, you can consider the number of students present in a class of strength 50 or 60, right? Then continuous random variable. So this continuous random variable, you can consider the number of persons waiting at the railway reservation counter, or the number of SMS passing through the mobile on a particular day, or the number of text messages posting in the social media like Facebook, Twitter, Instagram, whatever you can consider. So there is no limit for that here. So that is a continuous random variable. But when we assign some function to the discrete random variable, then it is called a probability mass function. Why we are assigning this function? To know the extent of that variable, how far it is useful, how we can calculate that. Means what is that velocity, angular velocity of the circuit? Is the circuit accepting more power or not? So that can be detected using this probability mass function here. So the probability mass function is denoted by P of X. And as you know that probability is always non-negative, and we are just assigning the value from the sample space. So always probability of Xi is greater than 0. And the first axiom of probability is probability of sample space is equal to 1. So that's why summation of probability of Xi equal to 1, where I equal to 1 to n here, right? Then, so you can consider the examples for discrete random variable as number of sales, number of calls during a particular interval of time, or shares of stock, people in line, or mistakes per page. So mistakes per page is limited here, right? But mistakes per book is not limited. It can be anything. So that again goes to the continuous random variable, right? So continuous random variable means a variable which takes countably all values, all possible values in general from minus infinity to plus infinity. So you can consider the height, age, time, temperature and weight of individuals or the persons waiting at the railway reservation counter, as I said before, and also you can consider the number of SMSs posted in that particular social website, right? So again, when we assign some function to the continuous random variable, then it is called a probability density function, which is denoted by small f of x. So why I am insisting here small f of x, because here we have one more, capital F of x is distribution function, right? So this density function is denoted by f of x, and again it is assigning a constant value from the sample space. So always f of x is greater than or equal to 0. But also continuous random variable takes the negative values since it is minus infinity to plus infinity. Then you may get a doubt that for negative values does the probability exist, right? So for the negative also, just we have to predict the event here. Just we have to calculate that. Even though you are failing, right? Let us consider a student result. So you have failed in your semester, right? So how many subjects, how many backlogs? So that is that one value. If you have passed, what is your percentage, right? So for failure also there will be some value for that. So that's why that function also should be greater than 0. And the second condition is here integral over minus infinity to plus infinity f of x dx equal to 1. So since the continuous random variable takes very huge values, it is highly impossible for us to make a sum of those. So that's why we are compressing that to integration here. So here you can take the continuous random variable examples as the time clock. So 24 hours it has to rotate. There is no limit for that here, right? Then next is the distribution function. So when we are taking a random variable, whether it is discrete or continuous, right? It has to be defined in different intervals here. So the function which is defined in different intervals is known as a distribution function. So the distribution function is denoted by fx of x, or simply you can denote it as capital F of x, and it is again comes from the sample space concept only. So that's a probability of x, right? But when it is a discrete random variable, here I have mentioned as DRV. DRV is nothing but discrete random variable. Then it is given by summation of P of x. And when it is continuous random variable CRV, then it is integral over f of x into d of x, right? So this distribution function has also some properties here, right? So using this distribution function properties, we can calculate the number of persons waiting in that, what is the mean number of persons, or what is the mean number of messages sending by a phone, what is the mean number of messages just visiting in the social websites and all. So that you can calculate using these properties of distribution function. So if you consider a and b as two constants, and also if a is less than b, then probability of a less than x less than or equal to b is given by f of b minus f of a. That means here a and b are two constants, where here these two are monotonically increasing functions. Then probability of a less than or equal to x less than or equal to b is given by probability of x equal to b plus f of b, capital F of b minus capital F of a. Just we have to note here, you have to use for distribution function capital F. Again, we have a relation between distribution function and density function also. Density function should be represented by small f of x, and distribution function should be represented by capital F of x, right? Then probability of a less than x less than b is simply f of b minus f of a minus of probability of x equal to b, right? And probability of a less than or equal to x less than b is f of b minus f of a minus probability of x equal to b plus probability of x equal to a. Since here a is less than b, just we have to remember that condition, right? So these are the some properties of distribution function. Then after that, random variable. Then after finding the random variable and classifying the random variable here, we have to find the expectation of that. Means the mean number of customers visiting that particular site we have to find, right? So to find that, we have to use the expectation, that is mathematical expectation. In general, mathematically we speak it as average, right? But here statistically we use the word mathematical expectation when we are talking about the probabilistic experiments. But when you are considering about the data, right, then we have to use the word mean, right? But now here we are talking about the deterministic experiments, so we have to use the word mathematical expectation which is denoted by capital E of x. But when x is a discrete random variable, then the mean expectation, that is the mathematical expectation, is given by summation over x into p of x. And when x is a continuous random variable, it is given by integral over x into f of x dx. Right? So here x can be greater than 0 or x can be defined from minus to plus infinity. When x is greater than 0, it is given as integral over 0 to infinity f of x dx. Right? And variance. What is this? Variance is nothing but here square of the deviation. So whatever the things you consider, definitely there will be a deviation in the data or there will be a deviation in the experiment. So that deviation can be calculated by squaring of that, which is nothing but variance, given by the formula in terms of expectation as expectation of x square minus expectation of x whole square. Right? So there is a lot of difference between expectation of x square. There we are taking the square of only x. And expectation of x whole square means we are taking the square of the mean here.